Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. In last lecture, we solved first four questions of exercise 2.1. Today, we are going to solve remaining questions of exercise 2.1. So, question number 5. Show that the equation x square plus within bracket mx plus c whole square is equal to a square has equal roots if c square is equal to a square times 1 plus m square. First, we have to find the discriminant, and we know that for equal roots, discriminant must be equal to 0. So, start solution. So, first we have to write the given quadratic equation into the standard form. So, for this, we have to open this square by using formula a plus b whole square, that is equal to a square plus 2ab plus b square. Here a is equal to mx and b is c. So by using formula we have m square x square plus 2mcx plus c square is equal to a square. Now we can take x square common from first two terms, so we have 1 plus m square plus 2mcx plus c square is equal to a square. Now we have to shift this a square to the left hand side of equation. So now shifting this a square to the left hand side of the equation, we have 1 plus m square times x square plus 2mcx plus c square minus a square is equal to 0. So now this equation is in standard form. So here a is equal to 1 plus m square and b is equal to mcx and c is equal to capital c square minus a square. As the roots are equal, so discriminant must be equal to 0. You know that discriminant is equal to b square minus 4ac. So now we have to replace these values. So 2mc whole square minus 4 is equal to 1 plus m square times, and c is c square minus a square is equal to 0. This can be written as 4m square c square minus 4. Now we have to multiply these two terms. When we multiply this one with c square, we have c square, and when we multiply this one with a square, we have minus a square. So plus m square c square, and when we multiply this m square with minus a square, we have minus a square m square. This is simple multiplication. This is equal to 0. Now we have to multiply this minus 4 to the entire values within the brackets. So here is 4m square c square minus 4c square plus 4a square minus 4m square c square plus 4a square m square is equal to 0. Now you can see that the sign of each term is changed. Why? Because we have here is minus 4 because of this minus. Now we can cancel this 4m square c square with minus 4m square c square. So we left with minus 4c square plus 4a square plus 4a square m square is equal to 0. Now we can take minus 4 as a common. So we left with c square minus a square m square. Now we have to remove this minus 4. So just dividing both sides with minus 4, we left with c square minus a square m square is equal to 0. Now we have to shift these two terms to the right hand side of the equation. So we have c square is equal to a square plus a square m square. From these two terms we can take a square as a common. So we left with 1 plus m square. C square is equal to a square times 1 plus m square. So this is the required condition. Question 4. Find the condition that the roots of the equation mx plus c whole square minus 4ax is equal to 0 are equal. Now we have it is given that the roots are equal. So we have to find the condition. So we know that for the equal roots, discriminant must be equal to 0. Solution: mx plus c whole square minus 4ax is equal to 0. When we open this square, we have m square x square plus 2mcx plus c square, and here is minus 4ax is equal to 0. Now we can we have to write this equation into the standard form. So first we arrange the terms m square x square plus mcx, and here is minus 4cx. We write this with 2mcx. So we have here minus 4ax plus c square is equal to 0. So now we can take common x, 2x. So we write 2 here and x here, so that this equation is in standard form. So now if we compare with the standard form of a quadratic equation, we have a is equal to m square, b is equal to 2 within bracket mc minus 2a, and c is equal to c square. As it is given that the roots of the quadratic equations are equal, so discriminant is equal to 0, and discriminant is b square minus 4ac. So b square minus 4ac is equal to 0. So by now we have to replace the values of a, b and c. So after replacing the values, we have this form of equation. Now we have to open square. So this is 2 whole square, that is equal to 4. And when we open the formula for this vector, we have m square c square minus 4amc plus 4a square. So here a is mc and b is 2a. So now we have minus 4 m square c square is equal to 0. We can take 4 common. So we left with m square c square minus 4am c plus 4a square. 4 is here and 4 is here. Just we here left with m square c square. In this factor, 4 is already common, so just we have to take here 4 common. So we have this term. Now m square c square, this is plus m square c square, this is minus m square c square. So this cancel out with this one, this cancel out with this one, and we have to divide. So after dividing, after cancelling and dividing by 4, we left with 4a square minus 4amc. Just we have to arrange this these two terms. So now we can take 4a as a common. So we left with a minus mc. So so dividing both sides by 4a, and we have a minus mc is equal to 0. So or a is equal to mc, which is the required condition. Question 7. If the roots of the equation, this is quadratic equation given here, are equal, then a is equal to 0, or a cube plus b cube plus c cube is equal to 3abc. So let's start the solution. This equation is in standard form. So here a is equal to c square minus ab, and b is equal to minus 2a square minus bc, and c is equal to b square minus ac. As the roots of the equation are equal, so discriminant must be equal to 0. So b square minus 4ac is equal to 0. So b is equal to minus 2 into a square minus bc whole square minus 4a is equal to c square minus ab, and c is equal to b square minus ac is equal to 0. Now when we take the square of this minus 2, we have plus 4. Here is also 4. So we can take 4 as a common. So this is common 4. So now we have to open this formula. This is a, you have to use the formula a minus b whole square. So that is equal to a square minus 2ab plus b square. Here we have to multiply this c square with this b square, and then then c square with ac, and then this minus ab with b square, and this minus ab with minus ac. So after simplification, we have this form of the equation. Now we have to divide 4 on both sides. So after dividing, we have this form of the equation. Now we have to multiply this minus, and we have to open bracket. So when we multiply with this minus, obviously we have to change the sign of each term. So we have a4 minus 2a square bc plus b square c square minus b square c square plus ac cube plus ab cube minus a square bc is equal to 0. So here we have plus b square c square, and here we have minus b square c square. So this value cancel out with this one, and here we have minus 2a square bc, and here we have minus a square bc. So we can write this as minus 2 and minus 1. We have minus 3a square bc. So we can write this as a4 plus ab cube plus ac cube minus 3a square bc. So now we can take a as a common. So we left with a cube plus b cube plus c cube minus 3abc is equal to 0. Since the product of these two terms is equal to 0, so either a is equal to 0 or a cube plus b cube plus c cube minus 3abc is equal to 0. Here this must be equal to 0. So just you have to write here, this is typing mistake, this must be equal to 0. Hence these are the required equation. We have to prove that a is equal to 0, either a cube plus b cube plus c cube is equal to 3abc. Just when we put this is equal to 0, then a cube plus b cube plus c cube must be equal to 3abc. So just you have to write this is equal to 0, and then you have to shift minus 3abc to the right hand side of the equation. So here is a typing mistake. Part 8, show that the roots of the following equations are rational. So for rational roots, discriminant must be positive and a perfect square. So first part, so this is standard form of a quadratic equation. Here a is equal to a into b minus c, and b is equal to b into c minus a, and c is equal to c into a minus b. Discriminant, we know that is equal to b square minus 4ac. So just replacing the values of b, a, and c. So here we have to open square. So this is b square, and this is c minus a whole square. This is 4a and c. So we can write these terms are multiplying. So we can write this as 4ac. Now we left with b minus c and multiply with a minus b. So now we have to multiply these two terms with this. So when we multiply b with a, we have ab. When we multiply b with minus b, we have minus b square. When we multiply minus c with a, we have minus ac. When we multiply minus c with minus b, we have plus bc. Here we can open square, and then we have to multiply with b square. After opening the square and multiply with b square, we have this form of this term. Here we have to multiply with minus 4ac. the entire values within the bracket. So after simplification, we have this form of the equation. So now we have to arrange these values in such a way that we can write this in as a perfect square. Since we have to show that the roots are rational, it means the discriminant must be a perfect square. So we can write this as AB whole square, we can write this as BC whole square, and why we writing this minus 2AC whole square, just I will discuss later. So now we have 2AB, 2BC. So we have, when we multiply this, we have plus 2A square BC. It means these two terms are positive. So that's why we're taking these two terms positive. And here these two terms are negative. So there must be one term is negative, either that term be a second or third. And we discussed here that the first two terms are positive. So the possibility that this term will take negative sign. So we're writing this as this 4a square c square as minus 2ac whole square. When we take square, this will be equal to this. So 2 BC, so B is BC and plus 2 into CA. So we can write this as 2 into CA. So we you have to remember that the formula A plus B plus C whole square, that is equal to A square plus B square plus C square plus 2AB plus 2BC plus 2CA. So so we write this in the in the form of a formula A plus B plus C whole square. Here A is equal to AB, B is equal to BC, and C is equal to minus 2AC. So we can write this in closed form, AB plus BC minus 2AC whole square. So this is the perfect square. So we can say that these roots are rational. Part B. This is a quadratic equation in standard form. So just you have to select the values of A is equal to A plus 2B, B is equal to 2 into A plus BC, and C is equal to A plus 2C. So discriminant is equal to B square minus 4AC. So here B is equal to 2 into A plus B plus C. This is whole square minus 4A, and this is C, value of C. Now square of 2 is 4, and just we have to write this A plus B plus C whole square minus 4. Now we have to multiply this with this. So after multiplication, we have this form. Now we know that the formula of A plus B plus C whole square is equal to A square plus B square plus C square plus 2AB plus 2BC plus 2CA. And here we have taken 4 as a common. So here we have to multiply this minus sign with these values. So after multiplying with minus sign, we have minus A square minus 2AC minus 2AB minus 4AC. Now we can cancel some terms. So this is positive A square and this is negative. So this cancel out with this one. This is the other terms which can be cancelled. So this is plus 2AB and this is minus 2AB. This is plus 2BC, and here is we have minus 4BC. So we left with minus 2BC. So after cancellation, we left with B square plus C square and minus 2BC. So this there is so here this plus 2CA cancel out with this minus 2AC or CA, same things. So now we left with B square plus C square minus 2BC. So this can be written as B minus C whole square. So 4 can be written as 2 square, and this is we can add one more step, that we can write this as 2 into B minus C within bracket, and this is whole square. So this is imperfect square, so we can say that the roots of the given equations are rational. Question 9. For all values of k, prove that the roots of the equations are real. It means we know that when the roots of the quadratic equations are real, it means discriminant must be positive. Discriminant must be greater than 0. So let's start the solution. Here a is equal to 1, b is equal to minus 2, k into k plus 1 by k, and c is equal to 4. We know that discriminant is equal to b square minus 4ac. Replacing the values of b and c, and after simplification, we have 4 into k plus 1, k plus 1 over k whole square minus 4. So opening square, k square plus 1 by k square plus 2, k into 1 by k, so k cancel out with 1 by k. So we have plus 2. Here is minus 4. So plus 2 minus 4, we have minus 2. So this can be written as, we have to show that this value is greater than 0. So we can write this as k square plus 1 by k whole square minus 2k into 1 by k. So this can be written as k minus 1 by k whole square. So this is the formula. When we open this, we have this value. 2 can be written as 2 into k minus 1 by k whole square. So this term can be written as in this form, and this shows that this is a perfect square, and this value is a greater than 0. So we can say that roots are real. So these values is square tells that this value must be a positive and greater than 0. So hence the roots are real. Question 10. Show that the roots of the equation are real. Again, we have to show that the discriminant must be equal greater than 0. Solution. Here a is equal to b minus c, and b is equal to c minus a, and c is equal to a minus b. So discriminant can be written as b square minus 4ac. B is c minus a, so c minus a whole square, and minus 4 a is equal to b minus c, and c is equal to a minus b. Just here we have to open square, and here we have to multiply. So after opening square and multiplying these two terms, we have this form of the equation. Now we have to multiply with minus 4, and after multiplying with minus 4 these all terms, we have this form of the equation. Now we have to arrange these terms so that we can write this in form of a square. So a square plus 4b square plus c square. So minus 4ab minus 4bc plus 2ac. So here first two values are negative and third is positive. It means first two values take the negative sign. First two value either first or second. So these two values are negative, and the third value is negative positive. So the second value will not take the negative sign, because second and third value when we multiply second and third value, we have this value. So if this is negative, then this term must be negative. So the only condition is that the second term will take the negative sign. So this we can write this is a square plus this can be written as minus 2b whole square plus c square plus 2. So this is a, and this value is b, and plus 2c bc. So this value is for b, and this is for c, and now ca. So this is ac or c, and both are the same thing. So we can write this whole term in closed form, a minus 2b plus c whole square, so which is greater than 0. Hence the roots of the equation are real. This is the today's lecture. So one thing you have to remember that here we are using the values of a, b, and c. You can take these values as a you can write this as a capital in a, capital B, and capital C. Why? Because a, b, c are involving here. So you can write the discriminant in form of a capital B square minus 4 capital A capital C. There is another way to write this that. So this is all about this lecture. Inshallah, in next lecture we'll discuss the cube root of unity. So Allah Hafiz.